Okay, so we've got another problem for you here. Here's one where we have a vector space. Well, what we have is a subspace of R4. So V is the span of these four vectors. And we're asked to calculate a basis for and the dimension of V as a subspace of R4. So this could be a very quick problem, but maybe not. If those four given vectors are all linearly independent, then yeah, we're done. That's the basis, and it's a four-dimensional subspace. But if we look at it for a little bit, we can see, no, it's not a linearly independent set. So the basis is going to be a smaller set of vectors, and the dimension of V is probably going to be something less than 4. So here to calculate a basis for this subspace, well, we can rely on some other types of problems that we've done. If we think about a basis for the row space of a matrix, okay, or the column space of a matrix, either one of those ideas will work here. So in other words, what we can do, depending upon how the spirit moves us here, we can think of these vectors as the uh, rows of a matrix. So that's one way of working this out. So this is a problem where there are several different correct answers. It just depends upon how you go about doing the problem, what your strategy is, and yeah. So here again, we can say, all right, well, if I arrange those vectors as rows of a matrix, then the basis for that set of vectors, or that subspace, I should say, is the same thing as the basis for the row space of that matrix. So how we go about from here is just to get this matrix into row echelon form. Now, I'm going to jump ahead a little bit here. It's not that difficult a task, though. But if we put this into row echelon form, we get 1, 3, 2, 1. That first row doesn't change because it's just row echelon form. And then our second row becomes 0, 1, 1, 1. And then the third and fourth rows are all zeros. Okay. And so the basis for V is simply the vectors 1, 3, 2, 1, and the second row, 0, 1, 1, 1. Okay, meaning any of the vectors in any of those four vectors given in those braces can be written as a linear combination of these two vectors. And because it was just two vectors, the dimension of V is 2. Now, we could have taken that matrix a step further and gone to reduced row echelon form. So again, this was row echelon form here. If we take this one step further and put this into reduced row echelon form, okay, which we could do. There's no rule that says that we have to, but we could. If we do that, then we'll have 1, 0, -1, -2, and then we'll have 0, 1, 1, 1. And then, of course, the rest of the rows will still be zeros. So another correct answer here would be 0, -1. I mean, 1, 0, -1, -2, and the 0, 1, 1, 1 again. Okay, so that's another totally valid answer there. Now, I said one of the ways of addressing this would be to think of the vectors as the rows of a matrix, but of course, we could have also thought of them as columns. So we could have gone this way, and this would have been fine too. We can think of each of the vectors given in the problem as the column of a matrix. And now we want to find a basis for the column space of that matrix. And so what we would do here is we would get this into row echelon form, but then it would be the columns that have the leading ones that tell us which elements from the original set are going to span the entire vector space, the entire subspace of R4 that we're given here. Okay, so again, I'm going to skip all of the row operations since that's kind of chapter 1 or unit 1 material. And so what's going to happen is our first row will still be 1, 2, 1, 1. But then our second row is going to be 0, 0, 1, -1. And then these are all going to be zeros again. Okay. So now it's not these rows that are going to form a basis, but it's the leading ones tell us which of the original vectors will be. So, or over here, we should say. So in other words, we have a leading one in the first column. Whoopsie. Uh, so that means that that first column, that'll be part of the basis. And then we don't have a leading one in the second column, but we do have one in the third column. And then we don't have one in the fourth column. So those two columns tell us the vectors. So 1, 3, 2, 1 forms a basis. I mean, is one part of the basis. And then 1, 4, 3, 2. That sort of gives us another answer. But note, each one of these bases has two components, has two vectors in them. So again, it doesn't matter how we generate a basis, one central thing is that it's a two-dimensional subspace of R4. Okay. All right. So I hope that made sense. I hope you got something out of it, and I will see you in the next one.